We are solving two NEET questions from moving charges and magnetism, both on the same concept. Let me solve this first problem. It says ionized hydrogen atoms and alpha particle with the same momenta enters perpendicular to the constant magnetic field B. The ratio of their paths is. So, when a charged particle is moving in a magnetic field, it experiences a force, maximum force BQV, that behaves like a centripetal force, so that the particle takes a circular path when it enters perpendicular to the magnetic field. So, V can be cancelled, radius r equal to mv by bq, where m into v is called momentum. It is given that both the particles are having same momentum, that means P is same, both of them entered into the same magnetic field, that is also constant. Then the radius is inversely proportional to charge. Then radius 1 by radius 2 equal to q2 by q1. q2 is alpha particle means helium 24, it has a positive charge of 2, and ionized hydrogen is usually having one proton and one electron. Ionized means its electron is removed and it is positively charged, that means it is having one proton. So, the radius is in the ratio of 2:1, that is the answer for the problem. In fact, the second problem is also the same concept, this problem. Look at this. An electron is moving in a circular path under the influence of a transverse magnetic field. The same reason it moves when it is entering perpendicularly, radius r as I have derived equal to mv by bq. The value of E by m is given for you, then what is the frequency of revolution is, that is the question asked. As you want frequency, we do not have that in our terms, but a linear velocity v and angular velocity are related as v equal to r omega. But further I can write omega is rate of change of angular displacement d theta by dt. When one rotation is completed, angle covered is 2 pi, time taken is called time period, 2 pi by t. Again 1 by time period is called frequency, that is 2 pi into n. So, omega can be written like 2 pi n. Put that omega in this equation, that implies v equal to r in the place of omega 2 pi n. This is the velocity of the particle, substitute this in this place. So, you will get the frequency that you need. Yeah, that implies radius r equal to m by bq, in the place of p r into 2 pi n. So, r and r will cancel, you want frequency n equal to, what is your equation then, bq by 2 pi into m. This q by m is called specific charge E by m, because it is electron, in the place of q you can write E. This E by m is now given for you, B is also given for you. B is given for you as 3.57 into 10 power minus 2 by 2 pi. E by m is given for you as 1.76 into 10 power plus 11. If you notice carefully, this 3.57 and 1.76 is very close to 2 pi, both of them can be cancelled. So, what is remaining is 10 power minus 2 and 10 power plus 11 is 10 power plus 9. So, frequency is 10 power 9 Hz, that is 1 gigahertz. That is the answer for the problem. So, in fact, both these problems are having a simple concept that when a charged particle enters perpendicular to the magnetic field, it takes a circular path of radius this much, because its centripetal force is the force experienced by it. That is how we have to solve this kind of problems. Thank you for watching.